Hi, this is Teacher Chella. Welcome to our math class. Today, we're going to talk about polygons. Alright, and we're going to talk about the classification of polygons. Now, so what is polygons? So we're going to talk a little bit of it since we have discussed it last week. So this is just a review. So what are polygons? So polygons is any closed shape which has 3 or more sides. Now we have also regular polygons. So it means that all sides are the same length and also their angles are at the same size. So examples of this are squares, equilaterals, triangles, regular octagons. Now, if we have regular, then we also have irregular. So what does it mean? They don't have equal length, sides, and angles. So what are the examples? Rectangles, kites, and trapeziums are an irregular polygons. Okay, but so too are shapes like this. So if you can see these shapes, notice that they don't have the equal length and of course their sides. So these are irregular polygons. So the 2 types of polygons that you must be specially clued up about are quadrilaterals and triangles. Now again, quad meaning 4 sides and tri meaning 3 sides. Okay, let's review a little bit of our triangles. Now our 4 types of triangles, as we all know. So we have the equilateral. So if you can see this blue side colors right here, so it means all sides are equal and also all angles are equal. Now all angles are equal to 60 degrees each. And then we can have 3 lines of symmetry. So symmetry again, when you cut it at the middle, then both sides left and right will be equal sides. So this equilateral meaning equal. So they will have 3 lines of symmetry. Now the isosceles triangle, notice we have red on the other side. So these sides are equal or they are the same. And of course our angle also are equal. 2 angles are equal and 1 different side and 1 different angle. Okay, so if you're going to cut this, so it will just have 1 line of symmetry. So this one right here. Okay, next one we have the right angle. So if you notice, this is the 90 degrees or right angle triangle, and all sides may be different lengths. So if you can see this one here, they have different colors. It means that their sides are different in length, and of course their angles as well, they don't have the same, and it may have 0 or 1 line of symmetry. Okay, now scaling. So again, notice that this here, they have different sides and different angles. So scaling, they have, or this scaling triangle, it does not have line of symmetry, no lines of symmetry. Next, quadrilaterals. Again, quad meaning 4 side. Okay, 4 sides of this. So we have this quadrilaterals example: square, parallelogram, and rectangles. Now each of these quadrilaterals, they have different properties. So again, if you can see our square, so we know already that all sides are equal to 90 degrees each, and then they have the same length. 4 sides are all the same, and then 2 pairs of parallel. Okay, and 4 lines of symmetry. So if you cut here, here, and that side and this side, so you will have 4 lines of symmetry because all sides are different, or all 4 sides are same length. Now the parallelogram, opposite angles are equal. So this one here will be equal to that, and this one will be equal to this. And then opposite sides are the same length. So this and this will be the same length, and this one, opposite side, will be the same length. And then we have 2 pairs of parallel sides. Now, it may have no lines of symmetry. Okay, so rectangles, it will be the same as a square. All sides or all angles, all four angles are 90 degrees each. Okay, opposite sides are the same length. So here, and this length here will be the same. And here also shorter side will be the same with the opposite. And of course, opposite sides are parallel and has two lines of symmetry, one here and one on this side. Next, we have rhombus. Now the opposite angles here and this one here, they're equal. And also this one and this one will be equal. Now all sides are the same length. Now the opposite sides are parallel. So this one and this one are parallel. And also the left and the right here will be parallel. And of course, they have the same size, so we can have two lines of symmetry. Okay, so we have special types of parallelograms. So we have here one pair of parallel sides. So this one here and this trapezoid or trapezium, these sides are parallel, and left and the right, these are perpendicular lines. Now all angles may be different sizes, and all sides may be different lengths as well. Opposite sides are parallel, and it may not have lines of symmetry. Height, one pair of equal angles. Okay, so this one here will be adjacent to that, or adjacent sides are the same length as well, and no pair of parallels. So this one is perpendicular, this one here to this is perpendicular, so no pair of parallels. And we can have one line of symmetry, and that would be here. Okay, now the other polygons, we have regular polygons and irregular polygons. So how do we know that these are irregular? So irregular, they might not have the same length. So regular polygons, all sides and angles are the same. So 1, 2, 3, 4, 5. So this shape or these polygons are named after their number of their sides. So this is pentagon, and hexa, 6 sides. Hepta or heptagon, so we can have 7 sides. And octa, 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. And then we have additional right here, 12 sides. So if you're going to count each of this, these are 12 sides. So we call it dodecagon. So decagon, 12. When you add do before the decagon, that would be 12 sides. Icosagon, these are 20 sides. Okay, it is not the perfect circle, but this one, if you look closely, it has 20 sides, so we call it icosagon. Next one. So we are going to talk about regular and irregular polygons. Now in this example, we have right here, these are the example of regular polygons. All right, and we have irregular polygons. So notice that their sides are not equal. Now identifying polygons. So we can have here 3 sides, we call it triangles. All right, and we also put them into groups, which is regular and irregular. So again, regular, all sides are of equal length, and all internal angles, inside internal, are equal. Now irregular are the opposite. Okay, any polygon that is not regular. So if you can look at this, quad meaning 4 sides, 4 sides, 4 sides. But then again, this is irregular because all sides are equal, opposite sides are equal, and this one, it is not. So 5 sides pentagon, so it could be shaped in different way. Then again, it has 5 sides. A hexagon can be shaped like this or like this. Again, you are going to just look at the size. If the length are equal, then this figure will be regular. So this one, of course, looking at it, the length is not equal. All right, so we have right here heptagon. There, it has 7 sides. So 1, 2, 3, 4, 5, 6, 7. So this one here, all sides are in equal length, so that is regular. But look at this. Of course, it doesn't have any equal length of the side. So 1, 2, 3, 4, 5, 6, 7. Again, it has 7 sides, but then the length are unequal. So this is irregular. Now this one here, we have 8 sides. So this is octagon. The length are equal. The length of this side is equal, so that is regular. And this one here, we will count 1, 2, 3, 4, 5, 6, 7, 8. So again, this is irregular because the length of the side is not equal. But again, it has 8 sides. So this is still octagon. Next, we are talking about concave and convex. So what's the difference? So concave have at least one internal angle greater than 180 degrees. So the angle here, at least one will be 180. And the convex have no internal angles greater than 180 degrees. All regular polygons are convex. Okay, so regular polygons, it means they don't have 180 degrees internal angles. So you have to remember the difference. So again, convex, no internal angles greater than 180 degrees. Concave, at least one internal angle is greater than 180 degrees. Complex polygons have a line that crosses one another. Okay, so if you can see, this is the line here, and then you have the line crosses on that part, and we also have another line here crosses in this part. So this is what we call complex polygons. Now let's have another examples of shapes that are not polygons. So of course, circle. So polygons, these are made up of line segments. So circles is, of course, you can't see any line segments here, so this is not a polygon. So again, any shape that includes a curve, so this is a curve right here, so it is not a line segment, it is a curve, so this is not a polygon. Now again, polygon is any closed, okay, side polygon. So this one, it is an open, so this shape is not closed, so it is not a polygon. Now, three-dimensional objects is not a polygon. Alright, so the interior angles are the angles inside the polygon, so that would be here. Okay, now let's look at these 2 examples. So any 4-sided shape is called a quadrilateral. A common quadrilateral is a square. So let's see. Find the sum of the interior angles of a square. So we have 4 angles right here. So 4 interior angles of a square are right angled. So we know already that it is equal to 90 degrees. So we just multiply by 4. So the sum of these 4 interior angles will be 360 degrees. Next one, let us look at an odd shape, quadrilateral below. To find the sum of the interior angles of the quadrilateral, we can find a point inside the polygon and draw lines from all corners to the point. So since we have right here, we're going to make a point, and then we're going to make a line from that vertex, okay, going to that point. So from here, so let's see, this is our point right here. So we're going to draw a line going to the end, and then we're going to make a line going to that end point. So we can see 4 triangles. So where are they? 1, 2, 3, 4 triangles. So the sum of the triangles of 4 triangles is 4 times 180. So again, we know that one triangle, the sum of that will be 180 degrees. So since we have 4, so we just multiply 4 triangles multiplied by 180 degrees each of the triangle. So 4 triangles equal to 720 degrees. So that would be equal to 1, 2, 3, 4. Now to find the sum of the interior angles, we need to subtract the angle in the middle. So this one here, that is a complete rotation, so that is equal to 360 degrees. So again, so we have our sum of the angles of the 4 triangles. We're going to subtract the 360 degrees, that is the one at the middle. So that would be equal to 360 degrees. All right. Now let's go to the next one. Let us look at a regular pentagon. Pentagon, regular meaning all sides of this are equal in length. All right, and then we can see that there are 4 angles. All right, 5-sided polygon. Now first, again, we will find a point within the pentagon and draw the 5 lines. So this would be the common point. So from that vertex, okay, or from the end point, we're going to connect it to that middle point. Connect, 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 connect. So again, there are 5 triangles. 1, 2, 3, 4, 5. There are 5 triangles in this big. Okay, the first one is this pentagon. Now the sum of all the interior, so this one here, interior, the inside of these 5 triangles. So we know that one triangle, the total of that one triangle angle is 180. So we just multiply it by 5 because we have 5 triangles right here. So that would be equal to 900 degrees. Now we are going to get the equal side. So again, the sum of the interior angles in the pentagon would be subtracted to this one here. The complete angle will be at 360 degrees. So the total of the sum of the interior angle is 900. We just need to minus it or subtract it from that angle, the middle. So that would equal to 540 degrees. Now, we're going to find each angle of a regular pentagon. So again, this is the sum of the interior angles in the pentagon. So we know pentagon has 5 sides, so just divide it into 5. So again, each of this, okay, is equal to 108 degrees. So this method of finding the sum of interior angles works for both regular and irregular polygons. Alright, so let's have a very quick review. Find a convex polygon from the following figures. So convex, you still remember? Convex are regular polygons. Okay, so A, B, C, D, E, F. So which of these figure are convex polygons? Ready? So we have A, D, and F. Regular polygons are convex, okay? So all the interior angles measure less than 180 degrees. Okay, next one. Which of the following is a regular convex polygon? A, B, C, D. Ready? So a regular convex, so that is letter C. Okay, so that's the end for today. See you next time. Bye.